All right, today we are going to be learning about how to solve systems of equations by graphing. And so just a quick intro to systems of equations. The word system, if you have heard that word in another context, it usually means a group of things working together. And so in this context, it kind of means the same thing. But we have a system of equations, and what we're going to be focusing on is linear equations, which we've just spent a lot of time working on, learning how to write equations of lines, how to graph equations of lines. So we're going to be building on that concept, but this time, instead of working with just one line, we're going to be working with a system of lines. And so we're going to be working with two or more equations, in this case linear equations, that share variables. And that's the definition right here, where it says system of equations. And an important thing to note is that because they have the same variables, which are usually going to be x and y, they can be graphed on the same coordinate plane. Because we have the x-axis and the y-axis, I can put two different lines on that same coordinate. And that leads us to the solutions. So if we think of just a single line, what the line means, I'm just going to highlight this one right here. We talked about this in our last unit, that a line is a set of solutions, where you can go and look, okay, if x equals this, what does y equal? If x equals this, what does y equal? And so any point on that line is a solution to that linear equation. But when we have multiple lines, or a system of equations where we have two lines, we're now asking, what is the solution to this system, or both of these equations? And so if we have two lines, oftentimes those lines are going to intersect one another. And so we have intersecting lines. And this is the most common type we will see, where there's a single point of intersection where those lines cross. And so we have exactly one solution, and we can actually name that solution with an ordered pair. So you look at what the x is, what the x value is, what the y value is, and you represent that as an ordered pair. And so that is usually how we're going to solve these, is that you're going to find the point of intersection. However, there are a couple of special cases. So if we look over here, we have the case in which you have two equations, and when you solve for y, you notice that they're the exact same equation. Okay, so when you graph these, you have two lines that are actually the same line. So they overlap each other. So if we're asking, what are the points of intersection? Well, if they're the exact same line, they have every point in common. Any point on this line is going to be a solution to both. So in that case, we have infinitely many solutions. It's not any solution, so this point here is not a solution, this point here is not a solution, but any point on this line is a solution, and it goes for infinity in both directions. So infinitely many solutions, and we can represent that with the infinity symbol. The last case that we have is when we have two parallel lines, and the definition of parallel lines is that they're two non-intersecting lines. So forever and ever, this line here and this line here will never cross or touch one another, because they have the same slope and they will never touch. They're equidistant from one another. So where's the point of intersection between parallel lines? Well, nowhere. They are never going to touch, so there's actually no solution, and you can symbolize that with like a zero with a line through it. So those are the three types of possibilities we can have when working with systems of equations in two variables. So the steps for actually solving these are right here. So step one would be to put both equations in slope-intercept form. And by this point, we should be really comfortable and familiar with slope-intercept form. That is y equals mx plus b. And what's so important about this form is that it enables me to quickly see what my slope is, which is m, and what my intercept is, which is b. And so anytime I have an equation in slope-intercept form, I'm going to want to write down what m is and also what b is. So we will be able to find those things and then plot them on the graph very easily. Once we have both equations in slope-intercept form, we'll be able to graph both lines using the y-intercept and the slope. And then once we have both lines graphed, we can identify the solution. So if they're intersecting, or if they're a different case, like infinite solutions or no solution. So here's an example. It says solve the system of equations by graphing. So we're going to follow the steps above. So step 1 is to put the equations in slope-intercept form, meaning that I want to get the y by itself. So first thing I'm going to do here is add 18 to both sides. And I'm left with 2y equals x plus 18. And then I'm going to divide everything by 2. So I'm left with y equals, right here, this is like a 1. And if I look at this, it's like 1 over 2. So I have 1/2, keep the x, plus, and then over here, I have 18 over 2. 18 divided by 2 is 9, so plus 9. So I can quickly identify m and b. So m equals 1/2 and b equals 9. So before I even look at the next one, I'm just going to go ahead and plot this so that I don't get confused. So I start with my y-intercept, which is b, that goes on the y-axis up here at 9. And for a slope of 1/2, it's positive, so it's going to be going up. So I'm going to go up 1 over 2. Up 1 over 2 right here. And that takes me off the graph, so I can also go down 1 over 2 to the left. I'm just going to continue this pattern all the way over here and connect those dots. Okay, there's my first line. Now I need to look at my second line. I have 6 minus y equals x. Once again, I want to get the y by itself. So I'm going to subtract the 6 from both sides. I'm left with a negative y equals x minus 6. If I divide everything by negative 1, it'll change the sign and give me positive y equals negative x plus 6. All right, so now once again I can identify my slope and my intercept. This negative here is like a negative 1, and this is my y-intercept. So I'm going to just write those down. M is negative 1, B is 6. So a slope of negative 1 means I'm going down, and I'm actually going down 1 over 1, but I'm starting at the point 6. So right here, down 1 over 1 is going to follow this pattern. And if I go up this way, I notice that it does cross my first line. All right, so if I was going to find the solution here, I would be looking for the point of intersection, which appears to be right here. Right here. So if I look at my x value, it's at negative 2, and my y value is 8. So the solution here, I can write it as an ordered pair, is x, which is negative 2, comma, 8. So that's how you would write your solution, and there's just one solution. All right, so now we're going to move on to an application of a system in the context of a word problem. So it says a used bookstore, and this word also should not be there. A used bookstore started selling used CDs and videos. In the first week, the store sold 40 used CDs and videos at $4 per CD and $6 per video. The sales for both CDs and videos totaled $180. All right, so when I'm solving a system of equations, first of all, let's back up and just think, if I didn't know that, say I didn't know I was learning about systems of equations, you might just think you're going to set up one equation like we have in the past. And you actually can set up an equation. We're familiar with this type of problem. But what you would need to solve is I would need to, because we have two things going on. We have CDs and we have videos. And in the past, we could set up, we used two variables before, but in order to actually solve it, I would have to tell you, okay, now say you sold 6 CDs, how many videos? I would give you the value for one and you'd solve for the other. So that's still possible. But in this case, actually, it's asking me to write a system of equations to represent the situation. I'm going to graph it, and it's asking how many CDs and videos did the store sell in the first week? So it wants me to solve for both. It's not telling me, oh, you sold 5 CDs, how many videos? Or you sold 2 videos, how many CDs? It's not telling me either. So I have to solve for 2 different things. And if I look over here, I notice that the CDs are down here. These are X. And the videos, I'm trying to color coordinate here so you can track with me, are Y. I'm trying to solve for both X and Y. And so in order to solve for 2 different variables, you have to use 2 different equations. You can solve for 2 separate variables with 2 equations. And so that's what we're trying to set up here is 2 different equations. So I'm going to look at the information given. It told me that the store sold 40 used CDs and videos, meaning that was the total number of things they sold. I don't know how many CDs and I don't know how many videos. I just know there were 40 total. So that's my first bit of information. The next bit is that it tells me how much each cost. So it was $4 per CD and $6 per video. So I know how much each cost. And then it says the sales for both CDs and videos totaled $180. So once again, it's giving me info about the total, but not the individual sales of CDs and videos. So in both cases, I don't actually know how many CDs were sold or how many videos were sold. So my goal here is going to be to write 2 equations that I can graph on the same coordinate plane and then find their point of intersection to find what X equals, CDs, and what Y equals. So the first info that I have here is talking about the amount that was sold, okay? They sold 40 CDs and videos. So if I'm calling CDs X and I'm calling videos Y, I can write the equation X plus Y equals 40. The number of CDs they sold, X, plus the number of videos has to equal 40. And so this represents the amount. I'm going to just jot that down here. This is the amount that was sold. X plus Y equals 40. But they also talked about the amount of money that was made off of those sales. So if we're selling the CDs, which are X, for $4, per means times. So 4 times X will tell me how much money was made off the CDs. And then also, they charged $6 per, which means times video, which is Y. So I have 6 times Y. And this tells me how much money was made off of the videos. And I know that the sum of the sales from the CDs and the videos was equal to 180. So this equation actually represents the money that was made off the sales. So I was able to come up with 2 different equations that I can now graph and see where they intersect, and that will give me the answer to my final question, how many CDs and how many videos. So going back to this first equation, I want to get Y by itself so I can graph it. So all I need to do is subtract the X from both sides. So I get Y equals negative X plus 40. And I'm going to identify the slope, which is -1, and my intercept, which is 40. So then I'm going to go ahead and graph this. So my y-intercept is at 40, that's up here. And for a slope of -1, the only thing is you've got to be really careful when you're doing real-world situations, because sometimes the scales will be different. So I want to make sure that they're counting by the same amount on both the x and the y-axis. So down here on the x-axis, it's counting by 5, 10, 15. It's counting by 5s. And on the y-axis, it's counting 5, 10, 15. It's also counting by 5s. So since both axes are counting by 5s, I can go ahead and count my slope as usual because it's a 1-to-1 ratio. But sometimes you've got to be careful because the y-axis might be going, 0, 10, 20, 30, and this one's going 1, 2, 3. So if they're different, you cannot count slope like normal, because then in that case, every time you go down, you're moving 10, and every time you go over, you're only moving 1. So that's not actually a correct representation. But since these are both counting by 5s, I can count my slope just like normal, which is -1, so it's down 1 over 1. So that's going to make this pattern right here. all the way down to my x-intercept, which is 40. And keep in mind, we've done this before. If you are doing a real-world situation or really any graph, you can also make the line just by finding your intercepts. You don't actually have to use the slope and the y-intercept. Okay, so that's my first line, and this line tells me the amount of CDs and videos that would need to be sold to equal 40. So in past, what we would say is, okay, if you sold 20 CDs, how many videos? You'd go up, oh, you sold 20 videos. If you sold 30 CDs, then you sold 10 videos. If you sold 0 CDs, you sold 40 videos. So you'd use that line to try your different options, but you wouldn't actually know the exact amount. But with the second equation, we'll be able to pinpoint exactly how many videos and CDs were sold. So over here, once again, I want to get y by itself, so I'm going to subtract the 4x first. And I get 6y equals negative 4x plus 180. And then I divide everything by 6. And I get y equals negative 4. Negative 4 divided by 6 gives me negative 2/3 x, and then 180 divided by 6 is 30. So my slope is negative 2/3 and my intercept is 30. So I'm going to start on the y-axis at 30, and because my scale is, they're both counting by 5s, I can follow my normal slope, which will be down 2 over 3. Down 2 over 3, down 2 over 3. I found my intersecting point, down 2 over 3, and my x-intercept. So if I draw this line, I should now be able to find my solution where both of these graphs meet, which is right here, which is 30 CDs and 10 videos. So what this means is, if I use these numbers, 30 CDs and 10 videos, that solution should fit for both equations, and so it should also answer my question nicely. So how many CDs and videos did the store sell in the first week? Well, they sold 30 CDs and 10 videos. All right, so those are the steps for solving both a just an algebraic system and solving that by graphing, and then also using a graph to solve a system in an application problem. So stay tuned for more examples and practice.